Emissivity and Absorptivity for Different Color Paints by Tyler Ogden and Orson Collister. Something that we thought was interesting was that black bodies cool faster than non-black bodies, and so we wanted to explore the effect different paint colors have on emissivity and absorptivity values. Black and white paint have been well documented, but there are many other colors that are hard to find documented anywhere, and so we wanted to test those colors and see where they fall in comparison with black and white with their emissivity and absorptivity values. Spray paint was used to paint the pieces of cast iron that were roughly 5 by 1.5 inches in surface area and half an inch thick. These pieces were used because that's what we had on hand, and mostly our paints are what we had on hand also. Initial testing was done just to see to compare known values that we knew with the black and white and plain steel, just to see if we could evaluate their emissivities. The chart on the left shows the temperature change as the specimens were heated in the sun, and the chart on the right shows the temperature change as they were cooled at room temperature. The greater difference in temperature between the black and white paint during the heating process shows that there will be a greater difference in the absorptivity values than the emissivity values. To further explore the absorptivity, more colors were used and the specimens were placed out in the sun. The piece painted flat black reached the hottest temperature after the 25 minutes, reaching 42.6 degrees Celsius, while the one painted white only reached a temperature of 36.2 degrees Celsius. All of the specimens heated fastest during the first 10 minutes than they did in the remaining 15. To explore the emissivities of the paints, the objects were heated to a uniform temperature and then allowed to cool in a room at room temperature. The data for the cooling did not come out as well or as pretty as the data for the heating, but it does appear that the cooling had more of a linear trend. As we expected, the emissivities appeared to not have as much of a spread as the absorptivities of the different colors, meaning that the heated specimens had more of a temperature range than the cooled ones. Using a flat black paint as a reference point, emissivity and absorptivity values were calculated. All of the emissivity values were greater than 0.9. The white paint had the lowest absorptivity value at 0.827. We expected to see lower absorptivity values and are not sure why they weren't lower. We don't know if the roughness of the cast iron played a part or if the thickness of the spray paint made a difference. If the experiment were to be repeated, we recommend that an infrared imaging camera be used to measure the emissivities of the samples, as this would be much easier and most likely more accurate.